Hello, everybody. I guess I need to do a small little explanation about number 17, part B. So here it is. Felt like, my job was kind of rushed earlier. So I figure let's try to be a little bit more thorough and more detailed. So then that way you can kind of see what's actually happening then. So as the problem itself says, I want to solve for 2x minus 1 divided by 3x minus 2. And I want to know for what values of x is all that going to be less than or equal to 1. Now, on the right-hand side, you can kind of see over here that, I don't know if you can see it, this is the graph of each one of those equations. So what I did was I went to my graphing calculator and I graphed out y is equal to 2x minus 1 divided by 3x minus 2. And I also graphed out just the equation y is equal to 1. And you can see where they intersect is going to be at this small little point over here. Now, this point, you can actually solve for it. And just to kind of save you a little bit of time, that is supposed to be when x is equal to 1 and y is equal to 1. So that means this coordinate right here is supposed to be 1, 1. Now, what's going to happen is when you try to solve for this problem normally without having to deal with like the different cases, you're only going to get the solutions that's going to be on the right-hand side. And here and I'm going to show that in just a little bit. But the question then is, how do you get all of this that's on the left-hand side? Because technically you can see that anything under that black line would be a valid solution because the y value for this equation is less than 1 then. Okay, so this we can get. The question is, how do we get this part? So the one thing that you have to remember is that here, this rule of thumb that we're going to have to use. Whenever you multiply or divide an inequality equation, where if the number is going to be negative, then that means the sign changes. So that means if I have an inequality and I multiply by -7, then the inequality is going to switch to the opposite direction then. Or if I divide by -3, the same thing happens. This is a rule back from Algebra 1, so hopefully by now you guys remember that one. So here's what I did then next thing. The next part is I looked at the denominator, which is 3x minus 2 is equal to 0. What I want to do is I'm going to take the denominator, set it equal to 0, so then that way I can see where this break is going to take place. Like, where is it that I'm going to have like two different cases? So at x equals to 2/3, that's where I have the vertical asymptote, as you can see vertically over here. And that's how I'm going to break my two conditions then. So here's what I'm going to write. If x is going to be greater than 2/3 right there, then that means that the expression in the denominator 3x minus 2 is greater than 0. So that means that if x is greater than 2/3, I don't have to worry about changing the inequality to a different sign because for all the values of x that's greater than 2/3, the result of the denominator will always be positive, so I don't have to change anything. So that's going to be the case 1 that we probably all solved for. Now, the second case, that's the part that we did not solve for. What if x is less than 2/3? Well, if x is less than 2/3, then the denominator is going to be 3x minus 2, which is less than 0, and that is going to cause the problem where we have to actually change the inequality sign. Okay, so here we go, case 1 and case 2. So in case 1, this is probably, again, the part that you guys all saw for. What I'm going to do first is I'm going to algebraically multiply both sides by 3x minus 2. Now, if I do so, you're going to get 2x minus 1 is less than or equal to 3x minus 2. And again, we don't change the inequality sign because all the values of x that is greater than 2/3, I don't have to worry about swapping it. So we're going to go ahead and solve for this naturally as we would before. Move the 2x over to the right-hand side. That gives me x is less than or equal to, move the 2 to the left-hand side. That is going to be 1. So now putting it all together, here's what it's going to say. So long as x is greater than or equal to 1, then that means that your inequality is going to be less than 1 then. So those are my set of solutions. And you can see that that's all that's over here on the right-hand side. Now, in terms of how does that deal with for x is greater than 2/3, well, it actually overlaps because look, so long, my condition was that x has to be greater than 2/3, and it is greater than 2/3 because x is going to be greater than or equal to 1. So then kind of putting it all together right here, this is just strictly for x is greater than or equal to 1. Okay, and that's the part that most of you guys have for as a solution. But now let's consider what happens if x is less than 2/3, which is basically going to be case 2. if I take my inequality and multiply to the other side, what will happen is I'll get 2x minus 1 is then greater than or equal to 3x minus 2. Note again, because x is less than 2/3, that's why I have to switch the inequality because the denominator is going to be negative. Now, if I try to solve for this right here, this will then give me my other solution set that is going to be over here on the left-hand side. So cleaning up the algebra, moving the 2x over to the other side, we get x, and then it's less than or equal to, move the 2 over to the left-hand side, which is going to say 1 then, okay? So here is the conclusion then, okay? I need to make sure, this solution set is saying, hey, you know what? If x is less than or equal to 1, then that means that all my values, when I plug it in for x is less than or equal to 1, it's going to be less than 1, which is what I want. But I need to also consider that x is going to be less than 2/3. There are two restrictions in this case, what you solved for and what you set up from the very beginning. So if you think about how that works out then, right, I need to satisfy both conditions. On the number line, here's 0, here's 1, and then here's 2/3. In my first case, my first initial condition, I have to make sure that is going to be x is going to be less than 2/3. In the second case, I'm looking for x is less than or equal to 1. Since both conditions have to apply, then that means my actual solution is going to be what they have in common, which is basically everything less than 2/3. So my solution that's on the left is going to be x is less than 2/3 then, okay? So that's going to be one solution set, and then this right here, x is greater than 1, is going to be another solution set. All right, thanks for watching. See you later.